Are we using groundwater sustainably? Let's talk about that. So how do we get water from the ground? Well, most groundwater in the United States and around the world is pumped out of the ground using a pumping well. When water is pumped from the aquifer, it reduces the level of the water table. A pumping well in the ground even pulls water from a nearby stream or even the ocean if nearby, because all water is connected. So as you may remember, groundwater residence times can be really long, in some cases even up to 10,000 years. So groundwater is a renewable resource if we pump groundwater only at the rate that it can be replenished via recharge into an aquifer. But it's a non-renewable resource if we're pumping that water out faster than it's being recharged. And in most cases, we do pump groundwater out of the ground faster than it's being recharged, which makes it a non-renewable resource. This map shows cumulative groundwater depletion across the United States, including Hawaii but not Alaska. And we see there are critical areas in the middle of the country, which is called the High Plains or Ogallala Aquifer, and also in the southeastern Mississippi Delta region and in Arizona and California. So let's talk about an important aquifer in the United States. It's known as the High Plains or Ogallala Aquifer, and the extent of it is shown in this map. It's under the states of Texas, New Mexico, Oklahoma, Kansas, Colorado, Nebraska, Wyoming, and all the way up into South Dakota. It's a very important water source for many farms. About 20% of all U.S. farmland is being irrigated with water from this High Plains or Ogallala Aquifer. And indeed, 200,000 wells have been drilled into this aquifer since the 1940s. We pump this large aquifer to irrigate crops and provide food for livestock in this region. In the image shown on this slide, the green circles show area where the land is being irrigated to grow crops using a pivoting sprinkler. So those are those green circles. If we don't find ways to conserve water in these states, agricultural productivity will decline a lot due to water shortages in the coming years. So why is this? Well, we are pumping this aquifer at a rate faster than it's being recharged. So much of the recharge of this aquifer took place during the last ice age, and it currently is only recharging at about 21 millimeters of depth per year, but we're pumping it at a rate of 55 millimeters per year. So that's more than a 30 millimeter per year difference. So as a result, the water table in this aquifer has dropped by more than 300 feet in some places. 1/3 of the world's biggest groundwater systems are already in distress, meaning that they already are being depleted of groundwater. When we deplete these systems of groundwater, we see other impacts on the environment, such as the draining of wetlands, land subsidence, and saltwater intrusion. In the Tucson and Phoenix areas of Arizona, the water table has dropped between 300 and 500 feet in some areas. These two pictures, taken in the same spot but 47 years apart, show how vegetation has been affected along the Santa Cruz River as the water table dropped, reducing water flows in a river that once supported a thriving riparian area but is now mostly devoid of trees. Land subsidence is a major issue in some areas of California, Arizona, New Mexico, the country of New Mexico, and many other countries around the world. The picture on the left shows just how far the land surface has sunk in the San Joaquin Valley in California as water was pumped out below the surface. Wow. When we pump groundwater near the ocean, it can pull salt water into the aquifer, causing the aquifer to become contaminated with salty water. This is shown in panel B on the image of this slide. In Los Angeles, they addressed this issue by adding a smaller injection well between the coast and the pumping well to push the salt water out of the aquifer and provide a barrier. Here are some resources used to compile this lecture.